I'm Colin Walls, and I'm here once again to talk about embedded software. Today I want to talk about a topic which may not seem typical of something that software engineers worry about, but actually it's something which does need their attention, and that is selecting the CPU for an embedded system. Now, selecting the processor used on any device is normally considered simply a hardware issue. The hardware guys are designing the electronics and they have a number of criteria they might apply. The obvious ones are things like the computing power. Does it have enough CPU power to actually execute the code that it's going to have? This is somewhat software oriented, but nevertheless the hardware guys will probably have some feel for what that might be. Then there's things like power consumption. That matters increasingly, of course. On-chip facilities, what else is on the chip other than the CPU and what capabilities does that have? And lastly, and quite importantly, price and availability are key issues. So these are the things that are normally used to select a CPU. And there's nothing wrong with any of those criteria. I would suggest, though, that there are other matters that should be considered. And these are largely matters which are in the area of software engineering. The first one is familiarity. Have you got a CPU that your team is familiar with? Do they know the architecture of a particular CPU really well? And if that CPU is good for this application, that is a major plus point because their learning curve will be reduced. They'll be productive that much more quickly. Next one is tools. You need development tools for the device. If you have the tools already and you're familiar with them, that's absolutely great. Otherwise, you need to make sure that good tools are readily available and are of good quality, of course. Not just any old tools, but you need tools that will let you generate really good quality code and debug it and so forth. Another kind of tool that you need to think about is simulation. Now, most CPUs, there are simulation models available for them which let you execute code before you have any real target hardware. That is increasingly important. It's important simply because you need to get on with working on the software long before the hardware is even beginning to be available, because software is becoming such a dominant part of the engineering process, and you need to start early. You'll probably want to use an operating system of some kind. It's very important to make sure that the operating system that you want to use supports the chip that you're considering as well. And the same goes for any other software IP that you have in mind. It doesn't necessarily make it a showstopper because you could consider a different OS perhaps. But again, that's a productivity aid. If you can use an OS you're familiar with the CPU that makes sense for the design, that's great for everybody. Lastly, an area which sounds like hardware, which is the support for low power modes and power management in general. It's very, very important in many modern designs to minimize power consumption, and that is largely a matter of the software taking control of the power consumption of the device. Because only the software knows how much CPU power is needed at any particular point and whether going into some kind of sleep mode makes sense. So these capabilities are needed by the software engineer, but of course they have to be incorporated into the hardware. So, lots of software issues that drive the choice of a CPU. I'm not suggesting that the software guys should make the decision about which CPU is used. That's probably going one step too far. But I think their input should be taken as early as possible and the decision to select which CPU taken as late as possible, so to avoid locking yourself into something which is unsuitable. Hopefully that guidance is useful, and you might want to share this video if you're a software engineer with your hardware engineering counterparts, because it does of course cross into their area. So that's all for now, and I'll be back soon with another embedded software video of some kind, and I look forward to seeing you then. But for now, cheerio.